Hi everyone, I am SS Kiran. I would like to discuss about execution and explanation of following base paper in MATLAB. Okay, actually in this project or in this paper, the main keyword of this paper, a switched capacitor. Okay, three-phase multi-level inverter using switched capacitor. Okay, the title is of this base paper, a new symmetrical three-phase MLI multi-level inverter, three-phase multi-level inverter using switched capacitor. Okay, generally these switched capacitors are used in power supply sections. Okay, uh, in this title we concentrate on switched capacitor basic units for especially renewable energy conversion system, right? Okay, actually these switched capacitors are replacing the power supplies. Okay, now come to the abstract part, right? Due to increase in availability of renewable energy sources, development of multi-level inverter topologies, what it is called, multi-level inverter topologies, has become an interesting research area for students and researchers in recent years. Okay, to further improve the effectiveness of inverter systems. Most of the time this system can be used in the inverter systems. Yeah, now that is called switched capacitor. We can also observe in the title also, the main aim is to design the switched capacitor in MATLAB Simulink, right? Right. This is the basic unit of switched capacitor. Right. I would like to enlarge, okay, zoom in, right? You can observe closely, right? Just simply drag, right? This is the basic units. Better to change around 350. That's fine, right? This is the switched capacitor basic unit. In this unit, we can observe one voltage source, right? That is the voltage source. Then one diode that can be connected as a forward bias, right? And capacitor charging and discharging purposes. We can observe the output across the load or capacitor or voltage. Okay, that is S1, S2 switches also, right? Now come back to the abstract part. The DC power generated is to be converted to AC source due to the predominance of AC source, right? Absolutely, right? Most of the time this can be used in the AC source due to predominance of AC source for transmission and household applications. Okay, in this abstract, the little bit disadvantage is there. MLIs are one of the effective power converter used to convert DC source to AC. Though the MLIs have a disadvantage of more number of components and complex control techniques, the less distortion factor of output waveforms. Now MLIs, obviously DC source, multi DC source inverter, right? Done. Now just come back to original signal or original title. See, in this switched capacitor, we can call it as a SCMLI. Okay, SCMLI stands for switched capacitor multi-level inverter. This also have to design, right? Done, right? See whether recording is going on, right? Test recording is going on, right? Okay. Now in this unit, the proposed topology. Okay. Second chapter. This is the basic switched capacitor unit. Just see, observe. Very important. We can also observe one tabular form also. Okay, now come back to the desktop. Whatever we have to execute, this first double click on MATLAB 2010 and come back to your original folder. This folder, I have designed all type of Simulink blocks. This is the documentation part, right? Then close it. This is the file is in placed in the desktop, right? Double click on MATLAB 2010A. Now it will be open slowly. Okay, just come back to the base paper, right? Okay, in this base paper you have observed proposed proposed system. This is the tabular form. Actually in switched capacitor you have observed two switches, S1 and S2. In capacitor can be used as a charging and discharging purposes. Okay, this is the complete diagrammatical representation, circuit diagram representation of proposed multi-level inverter using the switched capacitor. That is called general structure of proposed three-phase MLI, right? This has to be already designed. I will show it, right? Yes. Then I think MATLAB is open right now. Yes. Now observe there is a three junctions R, Y, B, three supplies. This is a phase 1, phase 2, phase 3, right? This is the general structure of proposed MLI. This has to be designed now, right? Come back to the MATLAB, right? This is the MATLAB. That's fine. Just open the desktop bar, click on desktop. Already I have placed the this, that's fine. This is the our main file, right? Recording is going on, it's fine now. Then come back to the file, just click here. Here very important thing is that is called main. This main is our source code. Click open, right? Open, right? This is our a small code for demo purpose by using GUI. This is very easy. Now MATLAB is ready. Here I have shown ready block. Yes, fine. See, that is a new symmetrical three-phase multi-level inverter using switched capacitor for renewable energy conversion systems. Right, it's fine. Yes, come back to the title also. Title is also same. That is renewable new symmetrical three-phase multi-level using switched capacitor basic units for renewable energy sources. Right, that's all. Okay. Now come back to the systems. Just click, that is the run button. That's fine. Just click here, run and simulation button. Then it will be open. See here one by one. Yes, click. Yes, here very important thing is you have to click on change folder, right? That is very important. Fine, good. There is a demo. This is a GUI, graphical user interface, right? In this base paper you already have discussed this general structured proposed three-phase MLI, that is called a multi-level inverter. Whatever you have observed in the figure 2, same I have designed in this Simulink MATLAB. Just click here, right? Click on that tab button, right? Okay, how it is open. See, observe here the start nearer busy symbol is enabled, right? Now see, that's fine. The block will be open, block open, right? This is the general structure of proposed three-phase MLI. Already I have discussed there is the three phases like R, Y, and B, right? Good. Come back to the general structure of your circuit diagram or our proposed system, whatever it is. Yes, R, Y, B, right? Good. Okay. Then this little bit zoom out, right? Here, a very important thing is how to design this subsystem or internal system, right? Click on or okay, I have shown R, Y, and B, right? Click on the R system. Let us take any one example. Let's start with the first one. This is the switched capacitor. That's fine. This zoom in closely. This is input voltage. Then switch. Let's open or double click. Come back to the MATLAB part. Okay. Here, where is the DC source? Just click here. That is the actually first we can start with the DC source, right? DC source. Okay, fine. That is the DC source. Yes, you can show here. This is the DC source. Good. This is the diode. Come back to say that is the diode, right? Fine. This is the switch one. Come back to switch one. That is the ideal switch. That's fine. This is the S2. That ideal switch 2. It's fine, right? Good. There is a small capacitor that for charging and discharging purpose. That's fine. Good. Right. Again, coming to the switch 1 and switch 2, right? Switch 1 and switch 2. Okay, this is the DC source. You have to give them repetitive signals to the both the diodes. Okay, with both switches also. Okay, and then come back to the extension of this switched capacitor. There is one more two switches also here connected. 1, 2, 3, right? One second one, yes, the switched capacitor 2, that's fine, good. 1, 2, that's one more, and that is the switched capacitor. These are all capacitors. Yes, one more DC source also connected. Let's come back to ground. Rest, that is the DC source. Okay, based on as per the proposed system I have designed as it is, right? One three switches. This is called the CCC here. Observe here, right? 1 and 2. Okay, this part is completely some like inverter part. This like also we can call the load part. Okay, this is the subsystem of the first block in this proposed system. This is the first. So both second, third also. Yes, right. Come back. Original system, original block. There's a click on Y B also same. Okay, so we can take some capacitors. Some loads are YB, a series capacitor, series or load. Nothing to worry. Anything you can take, right? Okay, right. This is the this is completely come back to Y. Yes, double click here. Yes, Y. That's fine. Good. Switch closed. Then come back to this third block. Just click here. This is the third block. That's fine. Okay. Yes. I have designed 3 blocks. You can do some adjustments. It's not a big thing, right? Yes. I have designed complete that is called general structured block also. This is switch 1 and switch 2 doing some mathematical calculations part, logical parts. We get output, we discharge across the capacitor, that is V. If it is 1 0, we get the switch 1 and switch 1 is closed, switch 2 is open, and it output across the capacitor is equal to 2 volts. Now we can start the simulation, that is the start button. See here, start simulation, right? We can take time period 48, right? Start simulation, right? Now come back to the base paper. In this we can see the results. Come back to down. Yes, that's fine. Yes, this is the 3-phase line voltages of the proposed MLA. Or these both are the same 3-phase MLA voltage. Okay, you can take any one. Yes, figure 5 and figure 7. It can be observed as the outputs. Yes, this is the 3-phase MLA pole voltages of the proposed MLA. This is also fine. You can observe these waveforms now. Yes, click scope 1. Yes, scope 1. That's fine. Yes, good. Right, this is the output of the first block. See, whatever mentioned in the base paper, same results we get, right? Come back to this voltage, this one also, that's fine, good. Yes, right. Charging and discharging, come, yes, charging and come back to the discharging up to some voltage level. Yes, then come back to the scope 2. We can also observe all the outputs at a time by using scope 3, right? Close it and come, then click scope 2, right? That's fine. A little bit increased, right? Come back to the base paper, it's fine. I start from the down 0 to same output. We can also observe from 0 to top 300, right? Based on the we can input, it will be get the vary, right? Scope 2, it's also fine. Yes, absolutely right, it's good result. We can also observe at a time all outputs in a single scope. See the scope, right? Okay, then click the scope 2 also. I have clicked right, that's fine. Okay, as it is base paper outputs, we also observed now. Slowly it can be acted as switching up to some peak level. Okay, then come back to the proposed system. There is some 3 2 volts here. Based on these results we get yes, right, 3 2V 1V is 0 volts. Okay, this logic is playing very major role, right? Just come back to the okay, again I will try see scope 3. Parallelly we can get 3 outputs, how we can start. Okay, see here, there's a 3 colors is there for difference. Yes, 1 2 3, right? Yes, that's fine. Okay, this is the designing of switched capacitor basic units for MLI. Okay, we can also observe all the blocks, even line voltages, 3-phase voltage of proposed MLI. Okay, at the same time pole voltages, everything we can observe in these blocks. Okay, right. Now yes, close it, that's a big thing, right? For auto scale purpose you have to click this button, right? Good. Okay, zigzag purpose, right, good. Okay, then auto scale, click auto scale, right? Closed here, right? Skip to scope 2, right? Closed scope, then scope 3, one more cross checking, that's fine. Output is fine now. Closed, okay, nothing, no problem. Then right, okay. This is the way to explain all the blocks, designing of a general structure. Already designed switched capacitor. There's some resistance across the load. That's close. Right, good. It's fine. Now again you have to simulate one more, that is called switched capacitor. There is analog to digital. This is only circuit level switched capacitor. Whatever we get the analog input, we can observe the digital output, analog to digital converter. So just click on run simulation button. Okay, based on the base paper we get some results. Yes, click on scope 2, right? See here, there is a digital output, ADC, this analog input, right? See here, I think somewhere is I have observed in the base paper, that's why I have designed this one, and that is analog, right? Fine. Yes, that's fine. This is the output. Okay, right, step by step increases. Okay, yes, this is the some. Okay, just outputs of the switched capacitor of different clocks. That's fine. It's closed, right? You can close now. Okay, the scope 1 and scope 2. Okay, same results we can observe in the base paper. Just you can check it, clarity. Right. Now, yes, this is the outputs modulation strategy proposed MLA for phase or like that. Right, you can close now. Nothing, no, that's fine. Just come back. Yes, recording is going on, that's fine. Okay, now come back to the program. Click start simulation, then this general structure. Okay, this is the cascaded MLA multi-level inverter. We have connect 3 inverters, that is a 3-phase, right? uh, right, recording is going on 20 minutes. Okay, uh, this is also MLA, also we can use it in this base paper. Multi-level inverter. In this block we have observed following base blocks. Okay, see the output waveforms. Almost all results we get in different Simulink blocks. Deeply you can observe, or closely you can observe. See here, right, this okay, this is MLA. Just no anything, just you can run this button to start simulation. Okay, we will get the values at the scope side. See the first one, what is the output? Okay, this better you can the second one, second scope. Now this is the output. So come back to the results. Come back to the results. Yes, this is the fine. This is also an output. This is also an output. Okay, this is also an output. See the output. We will get the values, right? Thank you. See the output waveforms, right? Okay, this is MLA, cascaded MLA. See one by one outputs, right? Click here. Okay, this is the one output waveform. That is 0 1 like that. Yes, come down. This is the 3-phase. That's why I can design like this. Yes, and one more circuit. Double click here. Then that is called ADC with MLA. Very simple. No need to execute. Right, closed here. Then come back to switched capacitor execution. Multi-level 3-phase space vector PWM technique. Somewhere PWM technique also used. That's why I have designed this PWM technique. See here, where is PWM technique? Okay, the PD PWM technique is used in this base paper. The pulse width modulation technique. Okay, right. Okay, modulation strategy for the proposed MLI. That's fine. Okay, this technique also very useful for executing the outputs. PWM technique based on modulation technique is implemented as discussed around 2.5 kHz. Okay, right. Let's come back to the basic block. Right. See here. I'm searching that where the PWM is there. Right. Come down. PWM. That is the basic unit. This is not this one. Right. Yes, come back to signal. Just click here. Multi-level space vector PWM. Okay. Right. This is the multi-level multi-phase space vector PWM. Okay. Then just you can simply run this one. Okay. PWM, where it is, yes, this is the phase disposition PWM. Okay, PD PWM is used as the modulation technique for the proposed MLI. Okay, that is the modulation technique for the proposed MLI. Now it will start. We can take around 5 level. We can also take 3 levels also. Yes, click here. We will get some outputs. These outputs also we can observe at the some circuits, some base paper. Right. Yes, slowly come down. Right. That is some output waveforms using modulation techniques. Okay, if it is 5 level, we can get the 5 outputs. If you can consider the single level, we get the single output. That's fine. No need too much. Just you people concentrate on only general structure of proposed 3-phase MLI only. That is our main Simulink block. Okay. Right. Okay, this is the total explanation of Simulink blocks and execution of Simulink blocks of switched capacitor using switched capacitor basic unit for MLI. Okay, now come back to the title. Come back to the original title. A new symmetrical three-phase MLA using switched capacitor. I will also show some documentation part of here. See, this is also completed documentation. If you have any doubts, just you can raise in the comment section, or just you can contact through mail in my description form also. Okay, I will explain you all the theories. Right, this is all the complete block. If you have any doubts, just you can mail. I have provided in my description. Okay, thank you so much. Thank you.